Hi, this is Bruce at Longevity's Learning Lab. Today we're going to talk about wire speed / amperage and voltage. These are the components that most basic MIG welders have on them, voltage and wire speed. Those are going to be your two controlling components. Amperage and wire speed are directly correlated. So MIG welding becomes a balance of voltage and amperage / wire speed control. When you are turning your wire up, if you don't have an amperage control on the face of your machine, when you turn your wire speed up, you are adjusting the amperage up. So the balance is voltage control and wire speed setting. Now you saw that if the voltage is down low, that you're not going to penetrate into the plate. You're going to have a weld that just sits up on top. If you're too hot, if your voltage is high, then you're going to burn through and put these flat welds out that can possibly burn through and change the chemistry of the steel that you're welding. So you're looking for maximum penetration. That's what a weld is, maximum penetration into both plates, and not to have the weld too cold that sits up or sits down too low. So it's up to you to, with experience, find the balance between these two, and there's so many factors that go into this, and experience is how you learn it. The type of plate, the material that you're welding, the thickness, and there's a lot of additional factors that go into it. So it's up to you to find the balance point of speed and voltage. So as you turn your amperage up, you can move from a short circuit process to globular to spray transfer, and I'm going to demonstrate how you can do that through amperage control. You don't have to change voltage at all to manipulate this process, as long as your voltage is high enough. First of all, you might say, you know, I only have, it's got a V and it's got 1, 2, 3, and 4. It's just got a couple of different settings for, and I'm guessing that's voltage. That's correct. You're setting your voltage to preset voltage current. So it's on a scale of whatever the top out voltage of the machine is. It's a 140. You're going from 20 to 70 to 100 and 15 to 140. Those are your click, 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 click. Those are your 4 settings. And then you say, well, my wire speed is 10, 20, 30, 40, 50, 60 to 100. I don't know exactly how many. Is that inches? Is it feet per hour? I don't know how I'm regulating that. So I'm going to show you how to regulate, how to figure out exactly what your wire speed is in inches per minute, which is the basic standard of wire feed speed, inches per minute. When you're turning up your wire speed, you're essentially turning up your amperage. Your volts can stay the same, but wire speed goes up, amperage goes up. I'm going to use Longevity's MIG Weld 250 MP here to demonstrate exactly what I'm talking about. I'm going to make some amperage changes, and you're going to see the results. So I got my phone. Any phone will work. Any phone that's got like a stopwatch feature in it. Just a cheapy phone that I have. And I've got a tape measure, a ruler, a tape measure, anything that'll measure inches, and you're set to go. All right, so this is what we got. I got my stopwatch ready to go, and I've got my wire cut off here at the nozzle. So we're just going to start these two at the same time and watch it go for 6 seconds, and then I'm going to hold this and stop at 6 seconds. All right, so 2, 3, 4, 5, 6. Okay, so now we have 6 seconds worth of wire sticking out here. So let me cut it off. And all we have to do is just measure this, see how long it is, and multiply it by 10. We got 6 seconds worth of wire here. So 10 times this is going to be 60 seconds worth of wire. So if we measure this, multiply it by 10, then we're going to have our inches per minute. So All right, so we kind of, we have wire speed figure out how many inches per minute you're running out of your machine. Now we're going to look at voltage and what voltage does at the same wire speed. I'm going to keep the amperage, the wire speed the same, and I'm going to crank the voltage from low all the way to high, and we're going to see how it affects a weld. Here's the three different welds. This is 14 volts, 14 volts, 21 volts, 3, 2, 1. Here's the three welds, 3, 2, 1. Here are the three welds, vastly different characteristics. 14 volts, 21 volts, 28 volts. This is essentially short circuit method where you're stop, start, stop, start, stop, start, 20 or 50 or 100 times a second. So it's a relatively cold weld. People like to use this method. A little higher amperage than this, but for root passes. This is globular transfer where we're melting, the arc is actually melting the wire and the wire is dropping off of the wire into the puddle now. Much better penetration. And this is spray transfer where the arc is very hot, high voltage, very hot arc. The wire is melting into tiny little particles and drifting down into the base metal. This is 3, 2, 1. So this is my wire at 250 amps. It's 8, this is 8 and a quarter, so it's a little bit less than that. We'll call it 8.1. So this is going to be 80 times 10. This is going to be 81 feet per minute. Three, two, 1. Okay, I've turned my amperage up to 250 amps. I left it at 21 volts, but here I have my wire. So I'm just going to start this and hold it for 6 seconds while I time it with my stopwatch. So let's go. 1, 2, 3, 4, 5, 6. A little bit long, but anyway, we're very close on this. So now I'm just going to cut this off and measure it, and that's going to give us our new wire feed speed for 250 amps. 3, 2, 1. So here's my wire, and here's my square that I'm going to measure on inches, and I'm coming in at 6.5 right there. So it's actually 6 5/8, and we're going to call that 6.6 inches. 6.6 inches, and that is, we're going to multiply by 10 because it's this piece of wire times, this is 6 seconds worth of wire, so we're going to multiply that by 10, which is going to give us 60 seconds worth of wire. So 6.6 times 10 is 60.6 inches per minute. Now I'm running at 35 amps at 21 volts, and I'm running 60.6 inches of wire per minute.